Welcome to SMART, the Synthetic Biology Modeling and AI Research Team. We're a group of students from high school to undergraduate and graduate programs, united by our passion for synthetic biology and the endless possibilities of artificial intelligence. This project is led by Dr. Yingji Tang and Dr. Yixin Chen at Washington University in St. Louis. Every week, we connect virtually on Zoom to dive into the fascinating world of synthetic biology and biomanufacturing. Together, we explore innovative ideas, solve complex problems, and learn from one another. In first of our initiatives, we focus on large language models application in higher education. We are testing how AI and large language model are affecting higher education. In the second project, we're using GPT-4o to extract valuable data from bioengineering papers. It's like having a research assistant that never gets tired. And in the third project, we're using large language models to construct tools for synthesizing and integrating knowledge. It's all about constructing AI systems that can truly keep up with the pace of modern science. For Project 1, we focus on the effect of large language models on higher education. The project involves two primary goals. First, we assess the performance of large language model in solving textbook and exam questions. The answers generated by the large language model are graded to evaluate its effectiveness in academic problem solving. This data can give us insights about how to design questions that are difficult for AI and how to design courses for better learning outcomes. Second, we use the large language model for literature critique assignments. Specifically, the model critiques journal articles and preprints. Some preprints, such as those for Nature Portfolio, have publicly available peer review comments. The critiques generated by the large language model are compared with these open comments from human experts to assess the model's ability to analyze and critique scientific literature. We can further use this open peer review to fine-tune a large language model agent for mock peer review, helping young scientists preparing for publications. I will outline the work plan for Project 2, which involves extracting data from published literature. We will be working with ImpactDB, a database managed by Dr. Garrett Rowe and PhD student Yufei Sun. The database already contains lots of data on Yaroya and Rhodosporidium. Our task is to add other species data to this website. The workflow is straightforward. First, we will search for relevant papers using Google Scholar. Our focus is on studies where synthetic biology tools were used to produce a compound in some microbial hosts. Once we gather the papers, the next step is data extraction using GPT-4o. We will follow the process outlined in the figure and aim to automate as much as possible using the latest GPT-4o API. After downloading the PDFs, we'll use a Python script to read the files and feed them into GPT-4o for processing. Yufei is currently working on optimizing this part of the workflow. Finally, we will inspect the extracted data to ensure accuracy and identify any errors. This step is crucial to maintain the quality of our database. The data extracted will be used for machine learning to guide future synthetic biology research. For Project 3, we want to further use large language models for knowledge mining and knowledge synthesis. We already developed a workflow network for knowledge organization. This workflow begins by pulling information from a variety of sources. Directly reading text often exceeds the context length of large language models. To overcome this, large language models analyze content, identify causal relationships, and build a knowledge graph. The knowledge graph itself is structured to distinguish between core and peripheral knowledge. Core knowledge represents common and interconnected research topics, while peripheral knowledge includes less common, unconnected topics. This is represented graphically with nodes symbolizing entities or terminologies and edges illustrating relationships such as article titles or citations. This workflow has three primary applications. First, it accelerates training and education by enabling researchers and students to acquire multidisciplinary knowledge quickly. Second, It streamlines the literature review process by providing a structured framework for organizing and analyzing articles. Third, it assists in experimental design by helping users troubleshoot, plan, and propose new theories for investigation. A significant advantage of this knowledge graph construction is its efficiency when compared to traditional large language model pre-training. Large language model pre-training requires immense computational resources, often involving tens of thousands of GPUs, months of training, and processing trillions of tokens. In contrast, our workflow focuses on domain-specific datasets, typically processing tens of thousands of tokens in just a few hours on consumer-level GPU hardware. This democratizes AI tools for synthetic biology researchers without excessive computational power. At Smart, we're making an impact. If you're as passionate about biology and AI as we are, we'd love for you to follow our journey or even join us. Together, we can push the boundaries of what's possible in synthetic biology and AI driven research.